Hello, I'll be doing the chemistry video today. Sorry if the video is going to be long. So basically, melting process, that means, what does melting mean? It means it's going to absorb energy. It needs energy. So it's endothermic. It's going to absorb energy so it can be able to go from solid to liquid. So 6 kilojoules is going to go in the beginning. Now, how are we going to choose between this one and this one? What does melting mean? Solid to liquid, right? So we're gonna choose this one where it goes from solid to liquid and it's gonna absorb that energy. Volatile substance is that when it can easily evaporate. So a volatile substance has a low boiling point. You have to memorize this. Okay, this one. Temperature increases as the liquid as there's less energy. No. So that means that's wrong because when there's more energy, there's more temperature. Less energy, less temperature. And the same one for this one. More energy, more temperature, not less. Okay, so when the water is boiling, this is not raising temperature. That's true. Because on the plateau, when we have that plateau on the heating curve, see this one? This part of the plateau, that's when it's boiling from a liquid to a gas. No matter how high you put the temperature, no matter how much heat you put, the temperature is not gonna raise at all. At all. It's gonna stay boiling, then the temperature is gonna increase. Then the heat absorbed by water is boiling, cause the liquid to evaporate. The only time, then you're thinking now, so where does this energy go? The energy does not go to the temperature, but instead it will increase the rate of evaporation. So the energy can raise the rate of evaporation, but it cannot raise the temperature when it's boiling or melting. Now they want the vaporization of liquid water. That means it's gonna go from, what does vaporization mean? It's gonna evaporate. From what to what? It's gonna evaporate from a liquid to a gas. Okay? And what does the evaporation need? It needs energy, so it will absorb energy. So it's endothermic if it will absorb. And how do we know if we choose this one or this one? It does not go from a gas to a liquid. It goes from a liquid to a gas. Vapor pressure is this pressure. It's the tendency of the liquid to go to water vapor, and it's also when the water vapor that has gone from the liquid, it's builds up some pressure because it's in an enclosed container. So that's the only explanation I have, and overall you just have to memorize that. So basically, when you have melting point and boiling point of a pure substance, it's gonna be fixed. It's gonna be that for every single time. But whenever you have the melting point and boiling point of a solution, yes, it's gonna be fixed every time if you keep it on the same amount. But usually it's variable. So what do I mean by variable? Let's say you have a solution and it's made of 70% lead and 30% sodium. 70% lead. So it's gonna mostly resemble the lead, because it's mostly made out of lead, but that does not only mean it's gonna have the full properties of lead. That means it's also gonna have a few properties from the sodium, from the 30% sodium. So it's a bit different. So it doesn't matter about the volume or the shape of the container, and it doesn't matter the molar mass of one of the components, neither the molar mass of 2+ components. It only matters the percentage of the composition of the metal. Okay, this one we have to do P1. Okay, this one is silly. Okay, so the temperature is constant, so P1 V1 is equal to P2 V2. So P1 is gonna be 120, and then P2 is gonna be, we have to find it, and then V2 is 2, and then V1 is 3. So you do 360 is equal to 2P. P is equal to 180. Sorry, this is the wrong answer. Yeah, this is the correct answer, equal to 180. Okay, this one. Yeah, so volume is constant, moles is constant. So P over T is equal to, P1 over T1 is equal to P2 over T2. 120 is over 25 plus 273. It's 298, and then this is gonna be 398, because remember you add from 273, you cross multiply. 120 times 398 divided by 298 is gonna be P, and P is equal to 160 millimeter mercury. This is gonna be the same thing, constant moles, but and constant pressure. So you do V1 over T1 is equal to V2 over T2. What's V? V is 4, and then V2 is unknown, we have to find it. And then we just add 273 here, and then 273 the other side. So it's gonna be 373 and 473. You just have to cross multiply, and then you get the answer. Okay, so basically this one, it shows in the equation they gave you, it shows if 1 mole of C5H12 burns, you will get 2000. 1 mole will give you 2000. So let's write it. 1 mole will give you 2000. Now they want to know how much will it give if it's 0.75. Just cross multiply. There's nothing hard in it. 0.75 times 2000 is 1500. This one you have to memorize it. When the vapor pressure becomes it becomes equal to the same pressure that's on the top of a surface of a liquid. When those two types of pressures are equal, that's when the boiling point is achieved. This has to be memorized. This is the same thing as the previous question, just they rephrased it. Okay, so like when the pressure at the top of the liquid and the vapor pressure are equal, that's when boiling point happens. This one you have to memorize something. That something is, wait, give me a moment to write this. Okay, when altitude increases, the boiling point decreases. Okay, just memorize this. Altitude increases, boiling point decreases. Okay, at the same temperature, kinetic energy of the same substance, no matter what phase it is, it will be the same. I will give an easy example. At 50 degrees Celsius, water like as an ice cube, and then water like as a liquid, and then water like as a gas. Sorry for the bad drawing, but okay, you can see this ice, this is water, and this is steam. They're all at 50 degrees. Okay? They're all at 50 degrees. But they're in different phases. But what? No, they are at the same degrees, not different degrees. What's wrong with me? They are at the same degrees, okay? Same degrees, same temperature. Okay? Different phases. What will happen to the kinetic energy? It will still be the same. Even though the solid and the gas, they're so different from each other, but it's at the same temperature. So what does that mean if it's at the same temperature? The kinetic energy will be the same. Only the kinetic energy. Okay? Now let's see what will happen with the potential energy. Potential energy is a bit different. Kinetic energy, this time it didn't do anything bad. Kinetic energy was actually very peaceful. It was the same thing. This time potential energy is the annoying one. Potential energy, it will increase as the phase as the phase evolves. So let's say that this is water at 50 degrees Celsius. Okay, it's at the constant temperature. Particles in a solid, liquid, and gas. This is water as an ice cube, liquid, and this is as vapor. Okay? Now, this will have the least potential energy. This will have the intermediate potential energy, and this will have the highest potential energy. Kinetic energy will be the same. Kinetic energy, same. Now, potential energy, see this arrow I'm gonna draw here? Potential energy, PE, it increases as the phase evolves. Is that clear? Kinetic energy, same. Potential energy will increase. Solution. What is the definition of a solution? 2 words. Homogeneous mixture. Homogeneous mixture. So that means that I don't want to see 2 different types of drinks out. Like you just want to see like one type of drink. So here I see that there's gas, and here I see that there's a drink. Wrong. This one, there's oil, water. There's two gradients. I don't want to, there's two different, there's like a boundary separating them. Those are two gradients. I don't want to see this. Ethanol and water. It's the same gradient. It looks like it's just water. It looks clear. It's good. Is this a mixture? Yes, it is. In fact, they're all mixtures. But all these three, orange juice, the fizzy drink, and the oil and water, they are heterogeneous. This is homogeneous, so this makes it a solution. Okay? I think the ethanol and water is clear. The orange juice will not seem very clear. The reason is because you will think it's actually that there's nothing in it, but you cannot forget about the pulp. The pulp is a solid and the juice is a liquid. That makes the orange juice a heterogeneous mixture. Okay? But does not make it a solution. This one, how many times I have to repeat this? N equals M over M. M is 0.109 and M is equal to 65.4. And that's equal to the moles. Do this, you will get 0.00167. And then what do? You get 1.67 times 10 to the power of negative 3. That's for the amount of moles of zinc. In part B, they're asking for the amount of moles of hydrogen. Since hydrogen and zinc are 1 to 1, you can see here it's 1 to 1, 1 to 1, and 0.00167. It's gonna be also 0.00167. So in scientific notation, they're both gonna be the same number. But now they don't want it as moles, now they want it as RTP. So if 1 mole is 24 decimeter cubed at RTP, then 0.00167 at RTP is gonna, you cross multiply 0.00167 times 24, you'll get approximately 0.04. And this is in decimeter cubed. In the question, they also specified that they did not want it in decimeter cubed, but they wanted it in centimeter cubed. So you multiply by 1000. So you do okay, it's right here. So 1, 2, and 3. So you get 40 centimeter cubed. So you have to find the syringe at 40 centimeter cubed right here. Now you have to write this equation and then balance it. So basically, NO as a gas plus O2 gas will give NO2 also gas plus 56 kilojoules. Do not write kilojoules per mole, write kilojoules, that's it, because that's in the word equation. In the official equation, do not write the word per moles. Let's balance it. So N is equal to 1, O is 1, and then plus 2, because here there's 1 and 2, and then N is equal to 1, and then O is 2. N is balanced, but here we have 3O, and here we have 2O. What can we do? You have two solutions. Since here the sum is 3, you can do here times 3 over 2, or you can just simply do here times 1 over 2. Times 1 over 2 on the left reactant side is easier. The reason is because if you do times 3 over 2 here, you're gonna have to edit this N. If you edit this N, then you have to edit this N. And if you edit this N, then you're gonna have to edit this O. So there's a long process. It's so unnecessary. Then you can just do this process and it's done one time. So just forget about the times 3 over 2. So what you do is times 1 over 2 here. So let me put here 1 over 2. But they don't want fractions. They want it in whole numbers. So you multiply this whole equation by 2 to cancel out the denominator of the O2. Now I have this equation. This is balanced, except for the kilojoules part, because now we have 2 nitrogen dioxide. So we just do 56 times 2, and then we get 112. Okay, let's balance this. Fe is 1, Cl is 2, Fe here is 1, and Cl is 3. You just do times 3 here, and then times 2 to make it 6. So times 3 times 2, it gets 6 here, and then 6 here. But now since you put 2 here, you're gonna have to make this 2. And now you have 2 iron. So you can just put 2 here. That's it. Now you have 2, 3, 2. Now you've balanced it. Now let's do the next one. Cl2FeCl3. Cl here is 3. Cl3 here is 2. Since they said 6 of FeCl3, we put it under the FeCl3 section. We do 3 times 6 divided by 2. So 3 times 6 is 18, divided by 2 is 9. Is this clear? Okay, you do 3 to 2, then to 6. You can replay the video if you don't understand anything. But overall, this is old material and I'm tired of repeating everything. Okay, oxygen to butane. We have oxygen and butane. Since butane is 2, and then oxygen is 13 here, and then we have 0.5 butane to x. So we do 0.5 times 13 divided by 2. 0.5 times 13 is 6.5, and 6.5 divided by 2 is 3.25. Now, we need just to convert this into RTP. So if 1 is 24, then 3.25 will be how much? We just do 3.24 times 24, we get 78. That's it. Now, let's see this next question. Air is 20% oxygen. Whenever you see this question, don't proceed, don't do anything. What you just do is you take the number from the previous question, take it, don't be shy, you put 78, and then after you just multiply it by 5. That's the only thing, because 20% is 1 over 5. Just derive it in some way if you're bothered enough. Derive it, and then you just do 78 times 5, and you get 390. 390 because they wanted 3 sig fig. Now they want the heavier gas. The heavier gas is always the one that takes a long time to diffuse. So basically the one that take a long time to diffuse, that means it's the slowest one. Because usually gases that are heavy, they're slow to move. Gases that are light, they're fast to move. So gas X, since it's slower to move, it's gonna be the heavier gas. Now we need to find the molecular mass of gas X. So we can use the rule V1 over V2 is equal to the square root of M2 over M1. V1 is gonna be 0.63 and 0.87. See here, V1 over V2. And then M2 is gonna be, hydrogen chloride is gonna be 36.5 because it's HCl. So 35.5 plus 1. And then you have M1. This is what you're gonna find. So you can cross multiply. You do radical 36.5 times 0.87 divided by 0.63. What is that gonna give you? That's just gonna give you the radical of M1. Do you want the radical of M1 or do you want M1? You just want M1. So since radical M1 is 8.34, around 8.34, and then you just square root this and you get 69.6. Okay? Okay. Now they want to place these 3 gases in order. We found HCl. It's 0.87. We just need to find CO2 and H2O. V1 over V2 is equal to radical M2 over M1. V1 is gonna be 0.87. V2 is what we're trying to find. M2 is gonna be 0.8. It's gonna be 36.5 because, oh no, never mind. That's V2. Okay. Let's choose CO2. So CO2, we can find the molecular mass, which is gonna be 12 plus 32, which is 44. And then of HCl is gonna be 36.5. 36.5. And then we do 0.8, we cross multiply 0.87 times radical 36.5 divided by radical 44. And then we get, it's gonna be equal to approximately 0.79 from what I remember. Now we can just do this rule again. V1 over V2 is equal to square root M2 over M1. What's V1? It's gonna be 0.87. V2 is what we're trying to find. M2, we're gonna now find H2O, so it's gonna be 18, because 2 plus 16. And then M1 is gonna be 36.5. So you cross multiply 0.87 times radical 36.5 over radical 18, and that's gonna be equal to V2. Now, I don't really remember the number because I don't have a calculator with me, but the number is sure, do it on your calculator. The number is 100% sure. From what I remember, I did it 3 hours ago. I remember the number was greater than 1. So let me just put greater than 1. Now, what do these numbers represent? They represent the rate of diffusion. So we can place them in order. Which one has the least one? CO2. The intermediate is HCl, and the one with the most rate of diffusion, I forgot the exact number, but I remember it was more than 1. It's H2O. Now we have these two gases at the end of a glass tube. When these two gases they react, they form a colored stain. They do this by diffusion, because they can mix with each other. Okay, choose the lighter gas. It's gonna be A. The reason for it is because it's gonna advance faster. It moved way faster for it to go here. B moved really slow. B took a long time to advance. You can see that the stain is beyond the midpoint of the tube, pointing towards gas B. That's because gas A took a really fast time to do it. Gas B took a really slow time to form this colored stain. So that means that gas A was moving faster. Since gas A moved faster and it advanced more, that means that it is the lighter gas. The volume occupied by one gas is equal to the volume occupied by the whole vessel. This question again, these questions. Okay. P1 V1 over T1 N1. So N is constant, just P, and P1 V1 over T1 is equal to P2 V2 over T2. P1 is gonna be 50. P2 is gonna be 100. V1 is gonna be 6, and then V2 is what we're gonna find, and then we do 177 plus 273. From what I remember, it's probably 450, and then if we do plus 273 here, it's gonna be 900. So now let's simplify. It's gonna be 30 over 45, and this, it's gonna be V2. So then you can cross multiply. You do 30 times 9 equals to V times 45. You just do 30 times 9 over 45, and then you find V2, which is this one, and then you get the answer is exactly 6. Okay, since there's so many givens, you have to use PV equals nRT. We have to find P. V is equal to 3, N is equal to, we'll use N later, R is equal to 0.08, and then T is equal to 57. And then we can do 57 plus 273, which is 330. The reason we do this is to convert it to Kelvin. And then we can do N, but we don't have N actually. We have mass and molar mass. But didn't we learn that N is equal to M over M? So can we just do M over M, and then the M is gonna be 0.044, and then the M is gonna be 2 because there's 2 hydrogen, not just 1. And then we can just simplify this, and we get 0.044 divided by 2, which is 0.022. And then we can say that P is equal to X, so we can just replace this by 3X, and then we can just divide by 3. We divide by 3 here, and we put this in the calculator, and we'll get 0.194 approximately. Okay, you're gonna learn, but you're gonna see in the next question something important about this. Vapor pressure is related to temperature. That's what you have to know. That vapor pressure is related to temperature. That's it. Memorize it. It's related to temperature. The next question states that when vapor pressure is constant, temperature is constant. And when temperature is constant, vapor pressure is constant. So you see how they're related to each other? When one is constant, the other one will also be constant. Molar heat of vaporization. Molar heat, what does molar heat mean? Either molar heat of fusion or molar heat of vaporization. It's the amount that needs to change 1 mole. So molar heat of vaporization, it's the amount that you need to evaporate 1 mole from liquid to gas. Molar heat of fusion, on the other case, it's gonna be change 1 mole from solid to liquid. Sorry for that noise. Okay. Also, we'll learn that for boiling point, when there's an increase in boiling point, there's gonna be an increase in the molar point of vaporization. Decrease in boiling point, decrease in molar heat of vaporization. Same for melting point. Increase melting point, increase molar heat of fusion. Decrease melting point, decrease molar heat of fusion. So basically, the lowest one, we just put it with the lowest one. Second lowest one with the second lowest number. Second highest number with the second highest number, and the highest number with the highest number. Okay, so the boiling point is the boiling point is the type of temperature when the vapor pressure is gonna be equal to the pressure that's found on the top of the surface. This one you have to memorize it, but just to, oh wait, no. Oh yeah, okay, fine. Boiling point is when the vapor pressure is the same as the pressure on the top of the surface, but I read this wrong. Also, boiling point can be summarized as when the vapor pressure is equal to 1 atm. Why is when the vapor pressure equal to 1 atm? Because 1 atm is the pressure that's achieved of the pressure that's near the surface. The pressure that's achieved near the surface is equal to 1 atm. Remember this, 1 atmosphere or 760 millimeter mercury. And when vapor pressure is equal to that, that's when boiling point is achieved. Now for this one, molar heat of fusion states that, fusion says that water, the energy it absorbs is 6 kilojoules. But vaporization states that water absorbs 42 kilojoules. So they want to melt ice cubes, so from solid to liquid. From solid to liquid, it's gonna be fusion, so it's gonna be 6 kilojoules. That's gonna absorb 6 kilojoules. Okay, so molar heat of fusion is like molar heat of vaporization, but instead of changing from liquid to gas, it's gonna be from solid to liquid, and it's still gonna be 1 mole. The same thing as I told you before, melting point will increase as molar heat of fusion will increase. Melting point will decrease as the molar heat of fusion will decrease. So choose the lowest one with the lowest one, intermediate with intermediate, and highest with highest. And then the last question states that a solution is a homogeneous mixture. Thank you so much. Sorry for this being so long. If you have any questions, please ask me privately, because I feel like I rushed through this because I wanted to keep it below the 30 minutes mark. Thank you.